Okay, so we're going to talk today about sector area and segment area. So sectors are, what is a sector? Like if I say the word sector, what do you think? Piece of something, yeah, it's a piece of a circle. So a sector is like a slice of a circle. So if you're talking about a pizza, a sector would be like the number of pieces that you have. So yeah, we do. Yeah. Or like a pie. Okay, so it's like a piece of that circle. So we break circles down two different ways. We break them down either in degrees, and how many degrees are in a circle? 360. And how many, if I were to talk about percentage in a circle, how many percent, what percent is in a circle? 100%. So every circle is worth 100%, and every circle is worth 360 degrees. Therefore, if I have a sector of a circle, I'm talking about a part of that circle, and we can relate it in two different ways. We can say it's either the degrees of a circle or it's the percent of a circle. So what we did on Friday and then in your rewind today was say, okay, if something is 25% of a circle, how many degrees would that be, or vice versa. So that's what you guys just did in the rewind. What we're going to do today is find the area of sectors, and to do that we kind of combine the knowledge that we already have. So we have to combine our knowledge of area of a circle and then also of that percentage or of that angle measure in the circle. So take a look at this diagram up here, which is circle C, and then we have sector ACB. ACB is the name of it because it goes from endpoint A to B, so the arc is AB, and then C is the center of the circle. And M degrees is the amount of degrees that is. So if you had to guess, about how many degrees do you think that would be?
Looks like 26.
Well, it's the whole circle's how much? 360. So half of it would be how much?
180.
180. So this would maybe be what?
90.
Maybe 90? Yeah, maybe about a quarter of the circle, right? So it'd be like 90 degrees. Okay, so we might say something like sector ACB is approximately 90 degrees, right? Because it's about a quarter of the circle. Now, if you know that, and you know the area of a circle, you can find the area of a sector. You just take the area of the circle, which is, how do you find the area of a circle? Pi r squared, and you multiply it by the degrees out of 360. So since this is about 90, you would take that and you would do pi r squared times 90 out of 360. Because 90 out of 360 is the fraction of the circle that this sector takes up. So if it takes up 90 out of 360 and the whole area of the circle is pi r squared, this would be the area of the sector. So for instance, in this one, first of all, what's the name of this sector? Sector MPN. We name them the same way we name angles. Okay, so you go from endpoint to the center, center to the other endpoint. All right, there's sector MPN. What's the radius? So then how would you find the area of the circle?
Pi
3 squared. All right, and then what fraction would go here? 80 over 360. Is it ever going to be different than 360? No. Okay, we'll always be out of 360 because the circle is always 360 degrees. So what would be the easiest way to do this problem?
Do the radius.
Probably do the radius first. Okay, which gives you what? So we've got 9 pi times 80 out of 360. So essentially, if I'm going to leave it in terms of pi, I'm basically doing 9 over 1 times 80 over 360. You're more than welcome to use a calculator, okay? But what's 9 times 8? 72. So 9 times 80 would be
720
over 360, which should be what? 2? And then because it's a circle, we have to include the pi. So the area of this sector would be 2 pi. The area of the whole circle is 9 pi, and the area of this sector then would be 2 pi, because 80 out of 360 times the area gives us 2 pi. And you can do all of that on your calculator. Again, if you're in math print mode, you just put 80 over 360 as a fraction. If you're in classic mode, just put it in parentheses and put 80 divided by 360. It's the same thing.
You don't
Okay?
have to do the calculator.
No.
To go to put
Like to multiply it times pi, you mean? No, I never do. I always leave it in terms of pi. So I guess you have a couple options, but I would prefer your answers like this. So that means when you're doing it on a calculator, just leave pi out of it and then put it in at the end. Okay? All right, so what would be my formula here? Well, what's my sector name, first of all? EFG. All right, and what would be the formula there?
Pi 6 squared.
And then what's my fraction?
120 over 360.
All right, what's 6 squared?
36.
So I'm going to end up doing 36 over 1 times 120 over 360. You can reduce this, or even just do it on your calculator. What does that reduce to? 1/3. So 36 times 1 over 3, which ends up giving me 36 over 3, which is what? 12. So my answer ends up being 12 pi. Okay, which should be bigger, the area of the circle or the area of the sector? Circle. The circle is the whole thing, the sector is part of it. So if the area of the whole circle is 36 pi, this should be smaller. All right, so it's 12 pi, which makes sense. Okay, questions on how you find the area of the sector? Okay, go. Oh, let's do 15 together actually. Let's do 15 together because then you guys can do 16. So what's different about 15? It has pi where? What's our radius? 4. So that means I'm still going to do pi times 4 squared. But what's my fraction going to be? It's always out of what? 360. What's the numerator? 3 pi over 2. So 3 pi over 2 is your numerator, which means when you put this in your calculator, because I'm assuming you're going to want to do this one in your calculator, how do you do it, or what do you have to put around this? You have to put parentheses around the whole, like the top, and then the whole thing. So you do parentheses, and I would just do it as, or what you can do is 3 pi over 2, and then divide that by 360, and then multiply that. But you can also do this without a calculator. So how can we simplify this just algebraically? How do I start? First of all, let's ignore pi, because we just have to bring it back at the end. What's 4 squared? 16. So I've got 16 times 3 pi over 2 divided by 360. How can I write this in a simpler way? Dividing by 360 is the same as multiplying by the what? Divided by anything is the same as multiplying by the reciprocal. So what's the reciprocal of 360? 1 over 360. So I can do 3 pi over 2 times 1 over 360. And what would I get on top here? 3 pi. And then on the bottom? 720. And then I'm going to multiply that by what? 16 over 1, or just 16. What's 3 times 16? 48. So it's 48 over 720. And then at the end I have to add back my pi. Okay? All of these you can do on your calculator. It just depends on how you want to do them. Yeah.
So that could be answered.
Yeah. I would start by doing 3 pi over 2, and then I would go divided by 360, and then I would multiply that times 16. Okay, and then that times pi. Alright? What'd you got?
It's like 0.013 go.
And then did you multiply that times 16? Yeah, so multiply that times 16 because that's your r squared, and then multiply that times 5. But that should be right. It should be a pretty small number. If I reduce this fraction, what could 12 goes into both of these, right? How many times does 12 go into 48?
3.
Close.
2.
Close.
4.
Good. 4. How many times does 12 go into 72?
7. 6. 5.
6.
8.
6, so that would be 60. Alright, how many times does 4 go into 4?
1.
And 4 go into 60?
9.
15.
15. Okay, so 1 over 15 pi. So it's a pretty small number. Alright? That sector is pretty small.
I got 1.4.
When you multiply times 16?
And by 5, right?
And by pi. Yeah, that's about right.
Oh,
Yeah.
I took about 5.
So it's
Oh, not 5 by pi. What?
pi r squared.
Pi r squared.
Oh, so
Parentheses m over 360.
Yes, pi r squared, parentheses m over 360, where m is the what?
Measure.
Measure of the sector, the angle of the sector. Okay, and in this case, this is kind of a complicated angle, but again, you can do that all in your calculator. Just do this first, divide it by this, and then multiply that times 16. Okay? Those are your options, or you can simplify it like we did right here with fractions. Whatever you're more comfortable with, it doesn't matter to me. You can have it as a decimal, as a fraction. I will figure out what you need. Okay?
If I
Yeah.
put it like this on calculator, just give me pi over 15.
That's fine. That's the same as 1/15 pi. 1 over 15 pi and pi over 15 are the same exact thing. So that's right. Good. So you answered it right. So you should be good then on 60.
Wait, what is 60?
What, how'd you get 16?
4 squared. So radius squared.
Wait, so I'm still confused. How
I would
do
do like this.
Which part?
Okay,
So I did this part first. So 3 pi over 2 times 1 over 360, because dividing by 360 is the same as multiplying by the reciprocal. So then we got 3 pi over 720. Then we multiplied by 16 because that's radius squared. So then this is r squared, and this is m over 360 basically. So that's m over 360, that's r squared, which gave us this. And then I set pi back in there just because you can't forget the pi. Okay, and then I just reduced the fraction. But again, I know I say like, and then I just did this, and then this, and then this. But it looks, I know it looks, when I say like, oh, I just did this, I don't think like, duh, can you not see that? Like, I understand that there are a lot of like mental leaps happening there, which is why if you're careful on your calculator, a calculator is a great way to do it. The problem is, if you're not careful and miss one of your parentheses, your answer is going to be off. Okay, so it's good to be able to at least understand what was happening here, but I get that it's not just like, come on, do it. It's really easy.
So if it's like the calculator kind of like how it's there,
Yeah.
it means pi over 15. If it's like another number, if it was like,
Anything, if it was like pi over 12, that's the same as 1/12 pi.
okay, and if it's like, if it actually has a number like 3 over 15, it'll give you 3 over 15.
3/15 pi, yeah. But you can also put 3 pi over 15. But yeah, if it were a number, it would be like 2 pi over 15 or 7 pi over 15 or whatever it is. The 7 and the 15 are like the fraction, and the pi can go off to the side or it goes in the numerator. Because again, if I did this, like if I did this times pi over 1, that's what I would get, right? 1 times pi is pi, 15 times 1 is 15. So that's what your calculator does because it's like the prettiest way to do it. Okay, so do the 3 that are left. So 13 and 14 are pretty basic, and then 16 has a bit of a difficult fraction.
I know it.
Okay, so that's sector area. So sector area again is those like pie slices. This is called a segment. So what is the difference between a sector and a segment? A segment is essentially just this part of a sector. Okay? So if you look at it like this, the area of the segment, this little slice here, is the same as the area of the sector minus what shape? Triangle. Okay, so there's a couple things you need to know. To find the area of a sector, we do it the same way, and then you just take away the area of the triangle. The good news is if you have a radius, you can find the area of that triangle, because how do you find the area of a triangle? Base times height over 2. And the radius would be the side, the base, and the height of the triangle. So as long as you have the radius, you should be good to solve it. Okay, so for this one, for example, we've got a triangle right here. If this is 12, what's this?
12.
Okay, that one's 12.
Yeah.
Is that the height though?
No.
No? Where would the height be?
Where the red is.
Like right here? Okay, so that would be the height. So basically this is my triangle. But how would I figure out the height there? What do we always use when we're missing something in a triangle? A squared plus b squared. This is 12. If the whole thing is 12, what's this?
6.
6. So what's my a squared plus b squared here?
12 squared.
12 squared is the
C.
C?
Yeah.
Okay, so 12 squared equals 6 squared plus b squared. What's 12 squared?
144.
Okay, so 36 plus b squared equals 144. Subtract it, and b squared equals
108.
108. And then you find the square root of 108. So b equals something between 10 and 11, closer to 10. But can someone find the square root of it?
108.
Yeah, square root of 108 is
10.3. 10.4.
10.4. Okay, so approximately 10.4. All right, so the area of the sector, this is 60 degrees. So then the area of the sector would be pi times 12 squared times 60 over 360 minus the area of the triangle. What's the base of the triangle? 12. What's the height? 10.4. And then I divide that all by 2. Alright, so I would do these in 2 parts. I wouldn't try to do it all at one time. I would do the area of the sector and then the area of the triangle or vice versa. Alright, and again, we'll leave this one as pi. What's 12 squared? So 144 over 1 times 60 over 360. Alright, so that ends up giving you 24 pi. Again, you can get that as a decimal if you want. And then here we would just do 10.4 times 12 divided by 2. So can someone do that part on a calculator?
Wait, really, you want to see it?
So 12 times 10.4 divided by 2. 62.4. Okay, can I combine those? No, not like it stands. If I turn this to a decimal, can I?
Yeah.
Yes, that's why I don't. Less work. Okay, so I just leave it like that. Alright, if you want to do it as a decimal, you're more than welcome to. This would be close to 75, so it would give you somewhere around 13. Alright, but again, I prefer less work, so I don't combine them. I leave those in terms of pi. Let me just reverse back up to what I did here instead of using a calculator, because again, you can use a calculator, but you don't have to. So 144 over 1 is just writing 12 squared as a fraction. How did I go from 60 over 360 to 1 over 6? Yeah, simplifying by 60. 60 goes into both. 60 goes into 60 once and 360 6 times. So then I ended up with 144 over 6, and then how did I get 24? Just divide that. Yeah, 144 divided by 6.
So you can't do that the first part first, which it gave me 480 times 17.
Okay.
And then I did the other part, but then I subtracted.
Yeah.
And it gave me 26.30.
Okay.
That could be it?
Yeah.
Really?
That means that's just you did the decimal part.
Okay.
Okay. All right. The only thing is, did you divide by 2?
Yeah.
Okay. All right. Because people just forget that part.
Yeah, it gave me
Yeah. So again, if you get it as a decimal answer, that's fine. Just be aware that this is the same as that.
And I have to put pi at the end of the
No, you don't, because if you put pi in the calculator, or did you put pi in the calculator?
Yeah.
Yeah, so if you put pi in the calculator, then you don't put it again.
Okay.
Okay. Alright, good question. Okay, so now, how do I find arc length? Arc length works very similarly, except instead of area, arc length is a part of the what? It's not part of the area, it's part of the circumference. So instead, it's the same exact formula, except instead of the area part, we have 2 pi r instead of pi r squared. Okay, so you have circumference instead of area because the arc length is just part of the circumference. So in this case, what's our r? 10. And what's our m? 90. So it will be 2 pi times 10, and then 90 over 360. What's 2 times 10? 20 pi. And then 90 over 360 is 1/4. So really, multiplying by 1/4 is the same as dividing by 4. So what's 20 divided by 4?
5.
5 pi. Okay, which would give you approximately like 15 point something. If you can figure out that, but you don't have to. Okay, so what's the difference between arc length and sector area?
Our intent is like
Okay, either way, R is always the middle line, right?
and the other one.
So for arc length, do you use area or circumference? Circumference. And for sector area, do you use area or circumference? Area. Both times, though, you multiply those by m over 360. And where does the 360 come from? Every circle is always 360. Okay, go ahead and do these 2, no, these 5, but this isn't really 5. This is just breaking this down in 3 parts for you. So you're just finding this area, but it's just breaking it down and finding the sector, then the triangle, then subtracting. These 2, you're finding the arc length. So this outside, right here. Go.